Let me share my screen. Share content. Screen 1. So are you able to see the PowerPoint? Hello?
Yes, ma'am.
Okay. So we'll start in exactly 1 minute, okay? Because and now can you see a whiteboard? ये whiteboard नजर आ रहा है सबको ये जो मैंने खोला हुआ है?
Yes, ma'am.
Okay, good. Okay, then we don't have any problem then. Okay. So it's 3 o'clock. I think we can start now. So can I start now? How many students are here? Okay, so we'll start. So how about yesterday's lecture? Was it understandable or was it a bit difficult? We were not able to derive time dilation lecture, but we will do it today's lecture and we will also derive length contraction. So as I was mentioning in the previous lecture, किसी के like से की आवाज बहुत ज़्यादा in background से. Okay, so I was talking about reference frames before, and if we have a reference frame S here, okay, and we have another reference frame S dash. What do you remember? What do you mean by inertial reference frame? An inertial reference frame is one in which Newton's first law of motion holds. Okay, so suppose we have S dash, which is moving at a velocity v with respect to in the x-axis, in the x direction, with respect to this frame S, okay, relative to this frame. So if we talk about the coordinate system, that one, this is y and this is z, okay? So now if I was talking about a situation where in this frame, if you have a light pulse is going in this direction, okay? And then you have a mirror here. It's getting reflected and then it will come back straight down and then you will measure basically this time it takes to move from one to another is the total time it takes for this event to take place from the light pulse to go here and then from here to here is known as T0, okay? T naught. And then, as I said in the PowerPoint, like I want to show you a situation here that if like it's going to be appearing to move in a triangular path, right? So the quantity T0 is known as the proper time of the interval between the event. It is the time taken. What is the difference between T0 and T? We said that time dilation means the formula for time dilation is this formula, okay? That means T0 is a time interval at rest relative to our observer, is a proper time. So for example, T0 is the interval on the clock at rest relative to an observer, that is a proper time. And T is the interval on the clock in motion relative to an observer. Okay? So, so what I'm going to say here is that we want to derive the formula for time dilation. And how are we going to do that? We need to draw a diagram for the possible situations. So suppose that if I open the whiteboard and this distance is L0. In terms of distances, this distance is L0, okay? So because this light frame, because this frame is moving in this direction, aren't we going to see, we're going to see something that goes like this and like this, yes? I hope this is making sense. हम कुछ इस तरह से देखेंगे. क्यों इस तरह से देखेंगे? क्योंकि the light pulse is starting from here, it's going to travel a distance L here, it gets reflected from this and then it comes back. But because this frame is moving in a velocity in this direction, So we're this t0 is a time it takes to go from here to here in this frame. In this frame. So if you see that where's this definitions here is a time interval on clock at rest relative to an observer. That's the proper time. So what we want to do now is we want to find out what is the time t in this frame for this event to take place. इस system में यहाँ से ऊपर जा रहा है तो it will take t0 divided by 2 time, and it will take half the time to go from this frame up from here down here to up here, and then half of this time to go from here to here. The round trip total time is t0. So we want to see कि इस frame में, which this one is the frame that's moving in the horizontal direction with velocity v relative to this frame. तो इस frame में time क्या होगा? और ये हम relativity की बात कर रहे हैं कि ये जो velocity v है is close to the speed of light. If it's in a situation where it's not close to the speed of light, then फिर तो कुछ और result होगा. फिर तो time it'll be the same. ठीक है? We're not doing relativity. It's not going to be affected. So let's see in the relativistic case, what will be the time it observes. Okay? So let's see if this distance, now let's do it in terms of Pythagoras theorem. Okay? We know if this is distance A, this is distance A. Okay? This is distance, what is this distance B? Call it B. Okay? And this is distance C. So what does Pythagoras theorem say? Pythagoras theorem says that A square plus B square, this is extremely slow, plus B square, sorry, this is not A square, this is C square. This is going to be C square plus B square will be equal to A square, according to the Pythagoras theorem, yes? So this C, we know this distance, the vertical distance is not going to change. Why is the vertical distance not changing? Because this frame is not moving in the vertical direction. Yeah, the frame is moving in the horizontal direction. So there's no time, there's no length. The length is not going to be affected in this direction. So it's going to be this C is equal to L0. Does that make sense? And then because
yes,
this,
ma'am.
yeah.
मैम एक चीज बता दें मैम, इसमें जो एक्स एक्सिस में क्या है इसमें, जहाँ पे आपने बनाया ट्रायंगल बनाया ना, जहाँ पे आपने ट्रायंगल बनाया ना ए बी और जो
ये
बी की डायरेक्शन में क्या है?
ये B क्या है? It's half the distance. Like for example, the light pulse starts from here. यहाँ पे शुरू हो रहा है और यहाँ for an observer that is in this frame, in S dash frame, will just see it going up and down, because this observer in this frame, this situation, this light pulse जो ticker है, जो भी है, it's not moving with respect to an observer that's also in the same frame, because even though the frame is moving with velocity v, the observer and this one and this clock over here, जो भी apparatus हैं, they are at rest with respect to each other. Like अगर दो बंदे एक airplane में हैं, they're sitting, they're at rest with respect to each other, na? But yes, for an observer that's in this frame is moving. So this light experiment is going to appear like this, कि यहाँ से light जा रही है एक, फिर यहाँ से reflect होके यहाँ वापस ऐसे triangular motion नजर आएगा. So we want to use Pythagoras theorem to calculate, we want to derive the time dilation formula, which is if as t0 is a time in this frame, t is a time for this event in this frame, then we want to prove that t is equal to gamma t0. And what did we say was gamma? Gamma is equals to 1 over square root 1 minus v square divided by c square. Yes? This is a relativistic factor. And then we will have a t0 here. Okay? So that's what we want to prove. We want to derive this. So now this length C is going to be equal to L naught because this is nothing is happening to this distance. So now what will our B be equal to? B, let's go back to the PowerPoint. So this distance B, because that frame, because this, what just happened? Because this frame is moving at velocity v and the time is t naught divided by 2 to move half of this distance, right? To move this distance. Because इस यहाँ से लेके यहाँ तक आने के लिए total time is t0. यहाँ से लेके यहाँ तक. तो यहाँ से लेके यहाँ तक t0 divided by 2 हो गया ना? And then the velocity of the frame is v. So this b, our c is equal to L naught. Our b, do you understand how b is equal to v naught divided by 2? V naught,
yes,
sorry, v naught into v into t naught divided by 2. V
Yes,
into t naught divided by 2. And what will our A be equal to? Because it's traveling at the speed of light, this is a light pulse. This will take half the time. So we're writing everything in terms of distances. This is L naught. The vertical distance will remain the same for the apparatus. It's not going to change because there's no motion of the frame in this direction. So, and this distance is V into T divided by 2. T divided by 2 or T not divided by 2?
एक ही बात है.
नहीं, एक बात नहीं होता. Just one second. That is T divided by 2. It says over here on its way to the lower mirror. Wait, just one second. It says that each mark corresponds to T naught divided by 2 is equals to N naught divided by C. First, I want to tell you one formula here. The time interval between ticks is the proper time, t0, and the time needed for the light pulse to travel between the mirrors at the speed of light is t naught divided by 2. The time it takes to travel from the bottom mirror to the top mirror is t naught divided by 2. किसी कोई person chat में कुछ कह रहा है. ये क्या है? Okay, well, anyway. Sorry about that.
यार जैसे मैम पढ़ा रही हैं, क्या कर रहा तू भाई?
Okay, so what I'm saying is that t0 divided by 2 is a time taken to move half the distance, yes? So t0 divided by 2 will be equal to L naught, which is the total distance this way, divided by C, yeah? Because this is the time taken to travel. Time is equals to distance divided by velocity, and it's moving at the speed of light, so we have this formula. Does this formula make sense? Like, for it to move half the distance up, like one way, it will take t naught divided by 2, and that will be equal to L naught divided by C, because that's the distance L naught, and it's moving C. Now we want to see over here that what's happening over here on its way from the lower mirror. So in the frame, we're talking about this frame, okay? So why did it make it T over here? It should be T naught, actually. Okay, so in this frame, so the time interval between ticks is T. Between this frame, the time interval between ticks is T because the clock is moving on its way from the lower mirror to the upper one in the time T over 2, the pulse travels a horizontal distance VT over 2. This makes sense.
T ही होगा क्योंकि T इस वजह से होगा शायद क्योंकि स्पीड ऑफ लाइट तो दोनों ऑब्जर्वर्स के लिए सेम रहेगी, तो इस वजह से T होगा यहाँ पे.
C T divided by 2 because the speed is going to be C because it's a light wave, and T divided by 2 because the time it takes will be the time total time it travels. This is one way. This is half the time it takes to go this angle, this distance, and the other half is this distance. Yeah. So we are only concerned with the half of the triangle, the first half of the triangle. Yeah, does that make sense?
Yes, ma'am.
So TC, this will be CT, this distance from here to here will be CT divided by 2. Because we're talking about as seen from, sorry, where did it go? We're saying as seen from this frame. This frame will see a total time T. And for that, a total time T, this will be half of the time. From here to here, it will take half the time. From here to here, it will take half the time as seen from S frame. So that's why B is going to be equal to not T naught, but it will be T. They're two different things. VT over 2. Do you understand why I'm saying this? And what will A be equal to? A will be equal to CT divided by 2. CT divided by 2. I hope this is making sense so far. Any
Yes,
questions?
ma'am.
Yes, sir.
Okay, so now I have to erase some of the board. I will erase this part of the board. I guess that's not, we can just, but I don't want to erase. Yeah.
A is equal to CT divided by 2 कैसे हुआ?
Oh, sorry. This C is the speed of light. Call this इस C को कुछ और कह लेते हैं. इस C को हम कुछ और कह लेते हैं. We don't want to confuse this C with this C. So इसको D कह लेते हैं. D is equals to, this was B, ठीक है? This is D, and this is D. Does that make sense now? This one is CT over 2 because the light travels at speed C, and the time it took to move from this point to this point is this time T divided by 2. Half of the time it takes to move from here to here. Does that make sense?
Yes, ma'am.
Okay. So this is D is equals to, sorry, this is L naught. Okay, so now I will erase this part of the board. This part, oops. This whiteboard is kind of strange, but we have to try using this. Okay. So now we will use the Pythagoras theorem, which says that b squared, ठीक है, plus d squared, ठीक है, is equals to a squared, according to this diagram. Yeah? So now if I open the PowerPoint again, this is our, can I just make this a bit, yeah. So this is our B, which is this one. So B squared, this thing. Can you see both things at the same time? The whiteboard and the PowerPoint, right? Okay.
Yes, sir.
Okay. And then this is our D squared. So we said that A squared is going to be equal to B squared plus D squared. So this is our formula. Now, if we want to, now this was our situation and we got a formula according to Pythagoras theorem for this situation. So if we want to algebraically solve this formula, rearrange this formula, take the t on the side of the equation, it will become c square over 4 minus c square over 4 minus v square over 4. Yes? T squared is equals to L naught squared. You know how to do this, right? Just take t on that side of the equation, make t the subject of the equation, rearrange. This is just some algebra, ठीक है? ये सिर्फ थोड़ा सा algebra है और आप करके फिर we get this equation. Do you want me to do this algebra, or I think you can do this, right? It's very easy.
Yes, sir, we can do it.
Okay, so basically we derive this formula now, ठीक है? यहाँ से t को subject बनाए equation का, ये हमारे पास आ गया. And from the previous equation, जो हमने कहा था कि what is this equation हमारे पास जो था? Do you remember this equation? This is for this t0 is the time for this event as seen by an observer in the same frame, in this frame as 0. So for that person, it will be t0 to go up and t0 to go down. So what will be the formula for that? T0 will be equal to 2L naught because it goes once up L naught distance and then once it goes down L naught distance, divided by what? C, because it's moving with the speed of light. So this is the formula for T0. If we put this formula now back into this formula, 2L0 over C we know was equal to T0 from that formula. So we put it in here, we got this equation. Now it all makes sense. Now we've derived the equation for time dilation. I hope it's making sense. Basically, what we're saying here is that T0, T is equals to, and now this equation over here, we know that gamma is 1 over square root 1 minus v square over c square. So I can simply replace this by T is equals to gamma T0. Yeah, can I say this now? And we know that gamma will always be greater than 1. Why is gamma always greater than 1? Did I mention that? And I think I mentioned that in the last lecture. Gamma will always be greater than 1 because v is always less than c. Yes? V will be some fraction of c. So when you 1 minus some decimal number will be less than 1. And then when you take the square root, that will be even small. That will be like, for example, if you take the square root of 0.25, what will be that? 0.5, right? 0.5, yeah. So something like that. So a fractional number, uska square root lenge, wo bhi fraction hoga. When you're dividing by a fraction, you will get a larger number. So that's why you will get a number. This will be greater than 1. So 1 over a fraction will be greater than 1. Therefore, gamma will always be greater than 1. Does that make sense?
Yes, ma'am.
Okay, so basically this quantity is always smaller than 1. Therefore, 1 over this quantity, which is gamma, will always be greater than 1. Okay? So in that case, this is known as time dilation. Dilation means to increase. So time, as seen from this frame, an observer in this frame, relative to an observer that's sitting in this frame that's moving with the velocity v relative to this frame, we'll see this event taking place in a longer time interval. That is known as time dilation, and this is an effect of special relativity. This is part of special relativity. Now I want to introduce, and we will do an example, and then we will do length contraction. Okay? Is this recording? Yes, it is recording. Okay. So now we will do length, we will do an example, and then we will do length contraction. So, so for example, if you have, this is example 1.1, if you, in the book, if you have a spacecraft that's moving relative to the Earth, okay? And a spacecraft is moving, we want to find, it's moving, an observer on the Earth finds that between 1 p.m. and 2 p.m. according to the observer's clock, 3,601 seconds elapsed on the spacecraft's clock. So basically, can I erase the board now? Yeah, I will erase it. Okay? Okay. So we're saying that T is equals to gamma T0. So that is going to be equal to 1 over square root 1 minus b square over c square, b square over c square, T0. Oops, T0. So what I'm saying here now, what the example is saying is that on the spacecraft, the clock, according to the clock on the spacecraft, the time elapsed is 36. You know that in 1 hour, like 1 p.m. to 2 p.m. is 1 hour. So 1 hour में 3600 seconds होते हैं. Spacecraft में 33,601 seconds elapsed हुए हैं as seen by the observer. ठीक है? So on the spacecraft, for the spacecraft, so basically this T0 is what? T0 is 3,600 seconds because for the person on the spacecraft, 1 घंटा गुजरा है, ठीक है? लेकिन for the person on the Earth, time ज़्यादा नजर आया है. So the spacecraft took the same time on the spacecraft was actually 1 second more. So now they're saying, can you calculate the velocity? Can you calculate the velocity of the spacecraft the spacecraft speed relative to the Earth. Yes, we just have to plug in the numbers and we'll get the answer. Yeah. So if T0 is equal to 3600, which is the proper time, what do you mean by proper time? Proper time is the situation I drew over there, that in the same frame, an observer is sitting here and an event is taking place, and the observer is in the same frame as the frame of the event. Okay? So that's the proper time without time dilation. Proper time is this T0, जिसमें time dilation का effect नहीं आया है. Okay? So if this is moving with velocity v and we have another frame that this is our S frame, this is our S dash frame. So the proper time will be this T0 that's seen in the same frame that is moving, the observer is in the same frame as the event taking place. And this observer sees T, which is gamma T0. So basically in this example, you just have to plug in the numbers. You'll just put T0 as 3600. You make T the subject. We know we have the time dilation formula. So make T the subject of the formula, and then you will get the velocity v, which is 7.1 into 10 raised to the power 6 meters per second, which is less than the speed of light. ठीक है, ये example ये समझ में आ गया सारा time dilation क्या होता है? Okay, I hope, are there any questions so far?
No, ma'am.
Okay, so I hope time dilation ये सबको समझ में आ रहा है. Special relativity अब सबको समझ में आना शुरू हो रहा है, ठीक है? I hope so. So now we will do length contraction, and this is we will do another situation. There are two basically things in relativity. एक तो time dilation होती है एक चीज, एक length contraction होती है एक चीज. So now we want to see so far what we were doing here. What we were doing here is that we were seeing a situation where if this is a reference frame, if this is a reference frame, ठीक है, and the clock is moving like this, sorry, not in this frame, but in this frame, in the other frame. Now we have another frame, inertial reference frame, and here it's moving up and down. So according to this, we'll see it moving like this and this. This person in this frame, S frame, will see this event going side, like in a triangular way. Now, what if we observe another situation where this frame is moving in this direction? Or we can say that, if we have a situation that some cosmic rays are coming from the Earth. So this is our Earth, ठीक है? This is our Earth frame. And we have some cosmic rays coming from the sky. We have some cosmic rays coming from the sky, so they're coming downwards close to the speed of light. And we want to see, suppose that we talk about cosmic rays and we want to talk about this distance that they are initially away from the Earth. Okay? So I will open the PowerPoint and tell you that first I will tell you a little bit about the theory. Basically length contraction में ये है कि अगर आपके पास यहाँ से ये जो distance है, if it's L naught, for example, as seen by an observer on Earth, ठीक है, यहाँ से वो देख रहा है cosmic rays coming from the sky, and cosmic rays are moving in the same direction. पहले तो हम इस direction में movement कर रहे थे ना? The frame was moving in this direction. Now, if the frame is moving in this direction, and if we have a distance length L, then this L is going to contract, like वो छोटा हो जाएगा length L, as seen by this particle in that frame. So for okay, this is a bit tricky, but let me show you an example. First, let me go through these two slides as well. So measurement of length as well as time intervals are affected by relative motion. So relative motion, it will affect not just time intervals, but it will affect length as well. But length opposite तरीके से change होता है. Like time dilation होती है, time increase हो जाती है, length on the other hand छोटी हो जाती है. But we have to be careful about which frames we're talking about and which frame of reference we are viewing from. So that's very important. So let's see. So the length L of an object in motion with respect to an observer always appears to the observer. Yeah.
मैम शहरोज कह रहा है कि उसका इंटरनेट स्लो काफ़ी मसला कर रहा है अभी तो उसने ज्वाइन की हुई थी क्लास लेकिन अभी वो कह रहा नहीं ज्वाइन हो रही तो उसकी अटेंडेंस कह रहा बता दें मुझे फिर अटेंडेंस लगा दें मेरी
Okay, मैं लगा दूंगी कोई मसला नहीं है. I mean at least he joined for some time so it will be okay.
Yes ma'am.
Okay. So the length the attendance sheet में उसकी आ जाएगी ना क्योंकि उसने join किया था एक दफा तो वो आ जाएगा. Okay, so anyway I was saying that the length L of an object in motion with respect to an observer always appears to the observer to be shorter than its length L0 when it is at rest. So let's do an example. What I want to say here is that if you have cosmic rays coming from the sky and we are observer who are on Earth. Cosmic rays are moving close to the speed of light like 0.998 c, which is very high, okay? And reach the sea level, okay? They reach the sea level and they take certain amount of time to reach the sea level. In T0, yeah, wait, I have to read this slide first to tell you about this one. So a muon decays into electron positron after the muon has an average lifetime of 2.2 microsecond. ठीक है? मतलब कि ये particle physics में ज़्यादा पढ़ेंगे इसके बारे में. Muon is a type of a particle, ठीक है? जो कि हमारे पास cosmic rays से आती हैं, ठीक है? Universe like बाहर से आती हैं, sun से वगैरह. Sun और बाहर से outer space से आता है, ठीक है? So muon is a type of a particle. And it has an average lifetime. What do you mean by lifetime of a particle? Means that after this lifetime, after this much time has passed, it will decay into an electron, it will decay into another particle. So that is what we mean by a lifetime of a particle. So it decays into an electron or a proton. A muon will decay into an electron or positron after an average lifetime of 2.2 microsecond. So now why am I telling you this is because if what I'm saying here is that if it moves with this velocity from the sun or outer space from wherever it's coming from, and if it has an average lifetime of this much, can I multiply this velocity with this time to get a average distance of over which it can travel? Yes? So basically it can travel a distance of only this velocity times this time, which is its average lifetime. So it takes 0.66 kilometers before decaying. It can travel only this much distance before decaying. So why am I telling you this? But muons are actually created at an altitude of 6 kilometers. So if I draw a situation where a muon is over here, this is the Earth, ठीक है? ये Earth है. And we have over here cosmic particles create हो रहे हैं. यहाँ पे muons इसको ऐसे लिखते हैं muons. Particles are created over here, and this is we want to figure out whether they will reach Earth before decaying or not. Their average lifetime is, what is their average lifetime according to here? 2.2 microsecond, ठीक है? Their average lifetime is 2.2 microsecond. 2.2 microsecond. ठीक है? So, and we're saying here now that the distance they can travel before decaying is 0.66 kilometers. But the actual distance, but what about time dilation? Will there be an effective time dilation as well? Time dilation. So what I'm saying here is that the distance d, they have, like, they can travel from the point they're created to the point to some, like, till their average lifetime is 0.66 kilometers. Why? Because I multiplied their velocity by the 0.66, no, wait. Yeah, 0.66 kilometers because I multiplied the time interval, the average lifetime, into its velocity. But now what we're interested in is that there will be time dilation effect. So as seen by an observer on Earth, will the time be dilated? Yes, it will be, because we are sitting on Earth, right? So what will be the time dilation effect? is gamma T0. Yes? So when we put that in here, 1 divided by, let's see, they have solved this in the PowerPoint. So if 2.2 into 10 raised to power 2.2 microsecond was the lifetime of the particle in the reference frame of the particle, of the particle, as in the reference frame of the particle, which this reference frame is moving in this direction. Now we're doing in this direction. So the time is going to be affected as well. So that according to the observer's frame of reference, अगर हम इसकी velocity is particle की velocity, which is the frame we're talking about, इसमें डाल दें इसकी velocity, तो फिर we get a time dilation effect. 34.8 microsecond हो जाता है. And then if we calculate the distance, what we want to know is that whether the muon created at a certain distance will reach the Earth or not. And the distance to the Earth is what? Basically, from our frame, we will observe muons are actually created at altitude of 6 kilometers or more. According to the muon's frame, it will not reach the Earth because 0.6 kilometers. Yeah.
मैम एक और तरीके से भी हम लेंथ कंट्रैक्शन के फार्मूले को ड्राइव कर सकते हैं कि इस तरह से कि अगर हम ये एक एग्जांपल लें कि एक बस में एक ऑब्जर्वर है और उसके हाथ में लाइट पल्स है ना, तो जब लाइट पल्स जब वो उसे ऑन करता है तो लाइट ट्रेवल करती है, तो एक जो बाहर खड़ा है बस से उसके लिए भी स्पीड ऑफ लाइट वही होगी और जो अंदर बैठा है ऑब्जर्वर बस में उसके लिए भी उसकी स्पीड उस पल्स की वही होगी क्योंकि लाइट की स्पीड वो कांस्टेंट रहती है. तो क्योंकि बाहर वाले ऑब्जर्वर के लिए उसके लिए उसकी बाहर वाले ऑब्जर्वर के लिए टाइम जो होगा वो डायलेट होगा. तो अगर टाइम डायलेट होगा तो फिर उसकी स्पीड को कांस्टेंट रखने के लिए उसकी लेंथ कम होगी. तो
तो हम भी इसी तरह से एक एग्जांपल करें, except we're using muons, ठीक है, in the situation which have not the velocity of light. They're moving with another velocity slightly less than that of light. So इस situation में, is everyone following? इस situation में, for example, like what I'm saying here is that this distance from here to here, it's 6 kilometers. 6 kilometers. Like muons are created 6 kilometers above the Earth. Now our question is, will muons reach the Earth before decaying or will they not reach the Earth before decaying? Now we can see this in two frames. One is the frame of the observer, which is on Earth, which is not moving relative. No, one is the frame of the observer, ठीक है, and one is the frame of the muon. Now this muon is moving downwards, तो उसका frame downwards move हो रहा है. तो हम जो देखेंगे, हम time dilation देखेंगे इस. Because we said before that if one frame is moving relative to the other, the observer is going to observe a time that's given by this one. Relative to the time, this one, what will T0 be? T0 is the average lifetime of this particle. So हम जो measure करेंगे, that will be equal to 2.2 into 10 raised to power 6 minus 6 seconds divided by this fraction, divided by gamma, which is 1 over square root this fraction here. And why am I using 0.998c? I'm using this because this is the velocity of the frame. The muon is moving at this velocity downwards. Is this making sense? Like 34.8 microsecond is the time that the observer on Earth will measure. So now if we calculate the distance, that the muon would have traveled, can travel before decaying as seen on Earth, that will be to its velocity into the time, dilated time. Is this making sense? That will be 10.4 kilometers, which means that the muon's 10.4 kilometers is greater than 6 kilometers. So the muons, according to the observer on Earth, the muons will reach the Earth before decaying. Does that make sense so far?
Yes, ma'am.
So everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
But now we want to look at the muon's point of view. Muon के point of view से time तो dilate नहीं हो रही क्योंकि उसके point of view में उसकी average lifetime ये है. तो उसके लिए, लेकिन in order for, if we are able to observe the muon that reaches the Earth, then according to the muon's frame, it should also see the light. It should also be able to reach the Earth according to its own frame. But in its own frame, it will, as I said before, the distance I calculated was only 6.66 kilometers in its own frame, because in its own frame, it travels with this velocity, and the time is its proper time, which is the proper time, which is the average lifetime it takes to decay, which is 2.2 microsecond. So there has to be some other effect जो कि muon देख रहा है, muon के reference frame में कोई और effect हो रहा है, जिसकी वजह से क्या हो रहा है, जिसकी वजह से it's able to reach Earth before decaying. So what will that affect? That effect is called time dilation, length contraction. And why do we see that? We need to, it's basically saying that it must be, in order for, now if you go to this slide over here, now we're talking about distances here. So h is the distance that the muon, now we said that 10.4 kilometers is the distance that we are observing, right? Because we said we calculated over here using this time that we observed, the time, dilated time that we observed. Okay? According to that time frame, and its own velocity, 10.4 kilometers is the amount of distance that the muon would travel according to the an observer that's on the Earth, right? So now what we want to do is we want to find out how much time, what's the distance that according to the muon's frame of reference. We want to see कि वो कम होना चाहिए, उसका distance कम होना चाहिए, तभी कम होगा, because कम होगा तो फिर ही वो Earth को reach करेगा. Does that should make sense, right? Because its average lifetime is small. Its average lifetime is small. Earth के हिसाब से तो time dilate हो गया है ना, लेकिन muon के point of view से average lifetime तो change नहीं होगा. तो फिर distance कम होना चाहिए, तभी तो वो Earth को reach करेगा.
समझ नहीं आ
नहीं समझ में आ
मैं
रहा?
अभी वीकेंड पे देखी कल से ये हुआ क्या है पूरे हफ्ते में
ओके, फिर आप जिसको नहीं समझ में आ रहा वो
मैम ये पूरा सब्जेक्ट ही रिलेटिविटी का इंट्यूशन बेस्ड है, तो ये इस तरह समझ आनी भी नहीं है, ये बाद में आराम से बैठ के सोचने से समझ आएगी, ये इस तरह समझ आएगी भी नहीं.
ये कौन बोल रहा है?
क्या कह रहे थे?
मैम इसके साथ एक फिलोसफिकल टच भी देना पड़ता है, सिर्फ मैथमेटिकल से ये नहीं समझ में आती.
मैं आपको सिचुएशन ट्राई टू एक्सप्लेन कर रही हूँ ना, with the help of whiteboard.
लाइबा चुप हो जाओ, आवाज नहीं आ रही तुम्हारी.
I know it's very, you have to use your intuition as well a lot in this, but try to read the book as well, and try to if you have questions you can always ask me, and I'm going to try my best to explain as much as I can. Okay? And watch the recorded videos again at your own time. Sorry?
लाइबा आपका माइक ऑन है, वो बंद कर.
यार ऐसे नहीं होता, असल में स्पेस नहीं आरएस दिया है इस पे.
लाइबा
okay, where were we? So what I'm saying here is that the distance that we see is h. The distance that, according to our frame of reference, the distance the muon travels is 10.4 kilometers because of time dilation. So according to the muon's point of view, uske point of view se distance kam ho jayega. The distance will be shorter, and the distance should be equal to 0.66 kilometers, right? Because we said that is the amount of distance. That is the amount of distance that it travels before it decays, right? So if we set h equal to 10.4 into h is equals to 0.66 kilometers, and that is going to be equal to 10.4 times this factor. So again, we are able to get this formula where we got a formula for time dilation. Do you understand how we got this formula? Basically 10.4 is this distance here, and 0.66 is distances. If you place them over here, you will get exactly the value of gamma, which is this term. Yeah? Yeah?
म्यू के पॉइंट ऑफ व्यू देखेंगे तो म्यू तो मूव नहीं कर रहा, लेकिन फिर ये जो सी जो स्पीड है ये फिर विद रिस्पेक्ट टू अगर म्यूऑन की रिस्पेक्ट देखेंगे तो
सॉरी व्हाट आर यू सेइंग
मैम मैं ये कह रहा हूँ अगर म्यूऑन के फ्रेम और रेफरेंस देखेंगे ना तो म्यूऑन तो मूव नहीं कर रहा होगा, म्यूऑन के रेफरेंस फ्रेम और रेफरेंस देखेंगे तो उसके हिसाब से फिर अर्थ मूव करेगी।
तभी तो मैं कह रही हूँ कि टाइम उसके फ्रेम जो एवरेज लाइफ टाइम है उसके फ्रेम में तो नहीं, क्या मतलब कि मूव नहीं कर रहा, उसकी वेलोसिटी ये है, उसके फ्रेम में
ये वेलोसिटी यस मैम उसके फ्रेम में जीरो होगी ना, इसका मतलब है कि अगर उसके फ्रेम से देखेंगे तो इतनी स्पीड से जो है अर्थ मूव कर रही है।
नहीं, उसके फ्रेम में फ्रेम और आप कंफ्यूज कर रहे हैं फ्रेम और पार्टिकल को, ठीक है, वो मूव कर तो रहा है। सो इसके फ्रेम में अगर उसकी वेलोसिटी ये है, आई मीन वी आर टॉकिंग अबाउट द फ्रेम ऑफ द म्यूऑन, but I mean the muon itself is the frame basically in the situation. Yeah. But what I'm saying is that muon is moving. It is moving and velocity ये है, उसकी average lifetime ये है. तो उसके frame में उसने इतना distance travel किया है, हमारे frame में इतना distance हुआ है time dilation की वजह से. तो फिर muon के frame में कुछ ना कुछ change और होना चाहिए जिसकी वजह से you are able to muon के frame में भी the same effect, it should be able to reach the earth. And basically what I'm saying is that muon के frame में it's 0.66 kilometers and that should be equal to 10.4 kilometers जो हम देख रहे हैं times something, and that something is a gamma factor. So we got this formula from here. So basically what we're saying here is that length as seen from the muon's point of view, क्योंकि ये value ज़्यादा है, gamma is 1 over this factor. Gamma is greater than 1. So this factor, this is smaller than 1. So time length contract हो गई है. You got it?
Yes.
समझ में आ रहा है ये length contraction और time dilation किस तरह से हमें derive किए हैं equations. So I think yeah, so we will go to momentum and we're going to derive the relativistic momentum. Last time जो मैंने now I will clear the screen. And हमने जो previous PowerPoint which I was starting with, मैंने कहा था कि classical momentum में P is equals to mv, right? And this is the classical momentum. Relativistic momentum में it's going to be equal to gamma mv, and that we're also going to derive. Or energy, the rest mass energy mc square होता है, और relativistically the total rest mass अगर ये rest पे हो, ठीक है, I mean rest energy, this is the rest energy, and ये हम करेंगे momentum के बाद, the rest energy, ठीक है, and if it's moving relativistically then the total energy we get is gamma mc square. तो I hope कि अभी तक जो हमने दो चीजें की हैं, that is the length contraction and time dilation, ये समझ में आ गया है?
Yes ma'am. Yes ma'am.
Okay, so can we start this momentum as well?
Time हो गया.
Time, there's still 2 minutes left.
2 मिनट में
इसकी भी derivation है, like इसकी भी derivation है, फिर conservation momentum इसकी भी थोड़ी सी है derivation. But okay, so
आज के लिए इतना काफी है मैम.
Okay, are there any questions?
मैम टाइम हो गया मैम.
2 मिनट रहते हैं अभी.
मैम 2 मिनट पहले आपने स्टार्ट किया था.
यस मैम.
Okay, Someone was saying something. Dilawes, you were saying something?
मैंने ज्वाइन कर दी थी क्लास बाद में.
Okay. Okay. I hope सबको समझ में आ गया है सब कुछ, ठीक है? If not,
ये आराम से सब लोग बैठेंगे, बुक को रीड करेंगे, फिर बहुत अच्छी तरह समझ में आएगा.
बुक आप गो थ्रू करें, ठीक है? और ये पावर पॉइंट्स भी देखें, वीडियो भी देखें अगर आपके पास टाइम हो दोबारा से, ठीक है? If you're not able to understand the book, if you have questions, you can always ask, ठीक है? We can do more discussion about this. And next lecture, we will do classical and relativistic momentum, ठीक है? And momentum के बाद हम conservation momentum, relativistic momentum derive करेंगे. उसके बाद हम energy examples करेंगे, mass and energy करेंगे, ठीक है? Then the formula that relates the momentum with the energy वो करेंगे with the help of examples, ठीक है? Okay.
Excuse me, ma'am.
Yeah.
मैम सॉरी, दरमियान में मेरा माइक ऑन हो गया था, तो वो मेरे भाई ने ना मुझसे एस्ट्रोनॉमी का पूछ लिया था कि इंटर्नशिप होती है या नहीं, तो वो समझने वाली आपके बारे में कोई बात नहीं कर रहे थे, वो बस मेरे से
नहीं,
था कि एस्ट्रोनॉमी यहाँ पे.
मैंने तो सुना भी नहीं था.
तो वो माइक दरमियान में ऑन हो गया था, तो मुझे पता नहीं चला.
It's okay, no problem. मैंने तो सुना भी नहीं था कि आपने क्या बोला है, तो
मैम वैसे एस्ट्रोनॉमी में इंटर्नशिप्स आती हैं
IST में या कहीं और?
कहीं और.
आपको सर्च करना पड़ेगा ना. कहाँ से आपको वेबसाइट से कोई इस तरह से डिफरेंट ऑर्गेनाइजेशंस की वेबसाइट्स पे जाके देखें अगर इंटर्नशिप्स लेते हैं. यू मीन विद इन पाकिस्तान, राइट?
यस मैम.
तो फिर आपको सर्च करना पड़ेगा. शो कन्वर्सेशन. ओके. So can I hide share? Okay. आपको कुछ सर्च करना पड़ेगा कि different organizations अपने internships अपने web pages पे internships का वो लिखते हैं ना, जो उनके postings होती हैं, तो आप search कर सकते हैं. या फिर कोई Facebook पे कुछ groups होते हैं जिसमें काफ़ी opportunities होती हैं, तो वो भी आप join कर सकते हैं.
ओके मैम.
ठीक है? Okay, so anything else? I hope कि सबको relativity कुछ ना कुछ अब समझ में आ रही है. It is a little bit, you have to use your intuition and you have to try to understand it by understanding the situation first and understanding the difference between different reference frames and that kind of stuff. And when you're able to picture the situation properly, clearly, then you'll be able to understand exactly what's going on. Okay?
Yes ma'am.
Okay. Yes ma'am.
So, yeah. Okay, so if there are no other questions, then we can, I guess we can stop here today. And I hope the whiteboard video में आ रहा होगा, I guess, I hope so. Because last time जो मैंने last lecture में जो whiteboard use किया था, वो MS Team का whiteboard था, तो वो recording में नहीं आया था. So, anyway. Okay, so if there's nothing else, then we can leave the meeting and we can end this meeting. And our next class, we already had 3 classes this week, yes. We had 3 classes this week. The first one was on Monday and Tuesday, and today is Thursday. So yeah. So next week we will have class on Monday, inshallah. Okay?
Okay ma'am.
Okay ma'am.
Okay.
Allah
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 Hafiz.
Hafiz.
Hafiz. Okay, I will end this meeting now.